Algebra, Equations, Exam Preparation Questions Part 4. You will find equations in the textbook, mathematics textbook, y equals mx plus c, Part 1, grade 10, 11 and 10, 11 from page 123. Now, in the previous videos, we did one unknown equations and we did quadratic equations. But now we're going to look at if there's two unknowns in one equation. Okay, so let's just go to an example. Okay, let's start with this example. So solve the simultaneous equations. Now, if you look at this one, you see linear to the power 1, 1, 1, 1. So both equations are linear. Very important. Okay. Now, if they don't say a method, elimination, I think, is the easiest one. Just go with elimination. So I name the equations. I make equation 1. I just want to make it a bit bigger that you see better. Okay. So basically 1, 1. And then I do the check. I see something must eliminate, something must cancel out. Now, when does something cancel out? Now, elimination works like this. If I want to eliminate 5, negative 5. So, because I must get 0. So, eliminate negative 2 will be positive 2 to get 0. So, eliminate 1. Do you see? I must make 1 just negative 1. So I'm just going to multiply with a negative. But remember, multiply it the whole way through. So negative, negative, negative. This is still equation 1. This is still equation 2. Now, this eliminate, I simplify, I get this, I divide, I get y. And then in any of the equations, I can then substitute. So I substitute and I get, if this is y, then this is x. And I say the solution is, if x is 7, then y is 3. Okay, that is if both equations are linear. Now, what I think I'm going to do, I'm going to, before I come back to this example, I'm going to go now and let you first do this one, because the other one's a bit more challenging. So I want you to stop the video. I will now go back to the example. I wanted to do it in one. I wanted you to do the comparison between the two. So I want you to stop the video and I want you to do number 1A as well as B. And again, you can continue the video as soon as you are finished. Let's start with number A. Now, that is usually very easy. It's not to say that elimination sometimes, and I'm going to show it to you. Not going to take an example, I'm just going to mention it, but that's at the end. I'm first going to start just by doing this. Equation 1, equation 2. So what am I going to do? This is 2, so what will eliminate 2? Negative 2. So, and don't forget to put the bracket. I multiply with negative 2. Then what do I get? Then I get negative 2x plus 10y. And that is going to be negative 80. I rewrite, this is still equation 2, and now rewrite 1, 2x plus y is equal to 3. That is equation 1. Okay, then I cancel, and this is 11y, and this is negative 77. Then I divide 11, and I divide 11, and I get that the value of y is negative 7. Then I write the equation down. So in equation, first one looks nice. And then in the place of y, I'm going to put the negative 7. So I'm going to get 2x, I take it over, so it's 3 plus 7. So 2x equals 10. I divide 2, and I get that my value of x is going to be 5. Okay. You can end by saying that, but it's not necessary. So therefore, x is 5 and y is equal to negative 7. Okay, let's do number B. Now, sometimes this was now a very simple one. B is a little bit if they bring in fractions, but again, it's not really. Just go. There's a lot of examples in the textbook. So just practice as many as possible. Okay, until you conquer it. Okay, this is equation 1, and this is equation 2. Okay, now again, you can focus on the halves and but I think let's make it easy. We're going to multiply both. We're going to take one to positive 6 and one to negative 6. So if we want to make this one, we want to make this positive 6. And then we're going to multiply here with negative 2 to make it negative 6. And I think that's going to work. So we just focus on that x. So then this is going to be 6x. And now, don't worry, if you still going to have a fraction, then just handle that fraction. You can make it a decimal. Maybe that is easier because it's 3 over 2. So it's going to be 1.5y. And then 13 times 3, it's going to be 39. It's still equation 1. Then this is going to be negative 6x. This is negative 4y. And this one is negative 34. Okay, so basically I'm just going to, this is still equation 2, and then I'm just going to get, if I'm going to simplify this, negative 4 plus this, I get negative 2.5y. And if I simplify this one, I'm going to get, this is 13, I'm going to get 5. So I'm going to divide negative 2.5, I'm going to divide negative 2.5, and I'm going to get that the value of y is going to be negative 2. And then I'm just going to substitute it in one of my equations. So take any one. So I'm just taking 2 because I don't want to work with the fraction one. So 3x, I take the second one, but it doesn't matter. You can take any one. So then it's 3x plus 2, and I put negative 2, and it's 17. And then 3x minus 4 equals 17. But if I take it over, then it's 17 plus 4. So 3x equals 21. Then I divide by 3, and I get that the value of x is 7. So again, it's not necessary that you do that, but therefore, when x is 7 and y is equal to negative 2. Now, as I said, most of the times you can do elimination. We're going to follow the substitution. If you get an equation like this, which is not always, but if the x and the y is in one term, in this case it was in two terms, so that it was in separate terms. So say you get something that's linear and you get 3x, and you will find this in the textbook. Just go to the textbook. 6. And you must then solve this one. Then you will follow the method which I'm going to show you now. Then you will do substitution. Then you will get x is equal to 5 over y, and you will take that and you will substitute it in this equation. Okay, so that not always to say that linear equations will always work with elimination. If the x and the y, if they are in one term, then you also do substitution. But let me take you to substitution. So it's very important that you can do both methods, because the ones which I'm going to show you now, they cannot be solved with elimination. And the reason why, and let me just take you, is because one is a linear equation and the other one, and I'm going to show you here, I just want to make a bit space that we see better, clean a little bit. Okay. This is a linear equation. Do you see that? But this one, you see the 2 there? That one is a quadratic equation. And now you cannot do elimination. Now you must do the method of substitution. And the reason why, because this is now exam preparation, and this is why I'm putting it. In a textbook, you will do it separate, and you will not do it in one example. But in this, I want you to prepare you. So check the equations. In this one, it was, it was a linear equation. And this was also a linear equation. Both was linear. Then you can do elimination. But if one is linear and the other one is quadratic, you must do. And it's not so difficult. And they love asking it. So again, practice until you conquered the method. But let's go through one. Okay, so here is my equations. This is 1, 2. So number the equations so that the working makes. So substitute the linear equation into the quadratic. So, and it's always very important that you say, for example, they can do this. They can say, oh, I just want my color to be better. They could have said y plus x equals 2. They could have made it a bit more challenging, starting by that. Then you must first make y the subject of the formula, like there. Okay, so very important for this method is that you get y equals or you get x equals. And it's 1, 1, and then you can put it into the other one. Okay, so this is now nice. They were already nice, and that's why I showed you. And in the place of y, we're just going to substitute, and that's what I do. And now I take everything. As soon as I see quadratic, I take always everything to one side, and I just simplify. And yeah, it's not always, but usually, it's not always, but let's say 90% of the time, it will factorize. So I get my two values of x, but if I get two values of x, it means I must get two values of y. And I'll show you this when we come to chapter 6. But in this case, and I just want to show you, it's always for me nice if you imagine the pictures. A linear equation is like this. A quadratic equation is like this. So basically, if you focus here, it's going to intersect at 2 points. So there's going to be two x values and there's going to be two y values. Did you see that? Okay. So there's my two x values. Now, don't substitute in the quadratic one. No, don't make life more difficult. Okay. Substitute in the linear one. So if I substitute in the linear one 0, I get 2. The negative 3, I get 5. But then write the conclusion very nice. So the solutions, so when x is 0, then y is 2. And when x is negative 3, y is 5. Sometimes they can say, write it as coordinates. They did not. Then you would say 0, 2, and negative 3, 5. But they did not. Okay. They were, if you go back to the question, they were just saying, solve the simultaneous equation. So they just want the two answers. Okay. Or the two sets of answers. Okay, now let's try one. Okay, I want you to take your time. Really, I want you really to try to do it on your own. Go to the textbook if you want to look at another example, and then you check the video to see if you're correct. Okay, but let's start with number C. And this is my linear, can you see? And it's very nice. Why is it so nice? Because they already made it 1x. So this is equation 1. And then they make x squared minus y squared equals 39, and this was equation 2. So I'm going to substitute always equation 1 into equation 2. Okay, and you can always, and in this case, this is now actually very nice. I like if they make it a bit more challenging for you, because do you see what's happening now? I'm going to take this, and I'm going in x, but it's quadratic, so please don't make a mistake. So it's meaning 7 minus 3y, and don't forget your square. Do you see that? So minus y squared, and now I have my quadratic equation. Now I like to do the short method, but please, I will rather do it here on the side. So 7 minus 3y, I will rather do the long one now for you. In AS, I would have gone for the short one. So 7 times 7 is 49. 7 times, so it's negative 21y. This times this, negative 21y. This times this, plus 9y squared. So it's 49 minus 42y plus 9y squared. Okay, so basically, it's going to be 49 minus 42y plus 9y squared minus that y squared. And I can even bring this 39 already over. Okay, did you see that? So please don't square. Do it on the side. There must be 3 terms at the end. Okay. Now I'm going to simplify and see what I get. So as soon as I'm going to, this is 9 minus that 1, so it's going to be 8y squared. And then it's only the 42, so minus 42y. And then this is plus 10. And that's equal to 0. And as if you can simplify, do that. Divide 2. So what do I get? 4y squared minus 21y plus 5, and that's equal to 0. Okay. And now I'm just going to see if it can factorize. Usually, as I said, not always, but usually. They will guide you, I think, if it cannot factorize. So it's 5 and 1, and it's a plus, so it's 4 and 1. Because it's 20 plus 1. It's in group A. Go back to my previous videos if you don't know what I'm talking about. So, so it's 20 plus 1. The signs are the same. Both gets this sign. And don't forget it's y's. So I'm ending up with y minus 5. And I get 4y minus 1 is equal to 0. Okay. So y minus 5 equals 0, or 4y minus 1 equals 0. So y is equal to 5, or 4y equals 1. So y is equal to a quarter. But now I'm not through. Now I'm going to substitute it. So x is equal in equation 1. So if y equals 5, okay. And then let's just go to my x, the equation. So x is equal to, let's just get that, 7 minus 3y. 7 minus 3y. So it's equal to 7 minus 3. And what is y in this case? In this case, it's going to be 5. So it's 7 minus 15. So it's going to be negative 8. Okay. And then the next one, if y is equal a quarter, then x is equal to 7 minus 3 a quarter, and that is going to be, okay, so it's 6 and a quarter. Because 7 minus 3/4 is 6 and a quarter. So I can end up very nicely say, but okay, let's make it red. Therefore, when x is 6 and a quarter, then y is equal to a quarter. And when x is equal to negative 8, then y is equal to 5. Okay, and that is how I'm going to do that. That's one. Let's do the final one. Okay, I'll just quickly make space. It's just a very long sum. But as I said, just conquer the method and just be very careful not to make unnecessary mistakes, because that happens sometimes in these long sums. Okay, let's go for the finals. D. And this is also the last one in this video. So, and then I'll continue in the next video. So this is again, now this is what I said to you. If you see that it's like this is equation 1, then change it. Make it x equals 7 plus y. Take the y over. This is still equation 1. Okay, this is equation 2. So substitute equation 1 into equation 2. Okay, so basically I'm just going to, so this is in the place of x, so it's going to be again giving me that square, that nice square. So let's just look that. So it's going to be again 7 plus y, I'm doing there, square, plus y, and that's 149. Now, remember what I said on the side here. Do it on the side. So 7 plus y, you can write it out also. Let me rather do it here. So make it 7 plus y 7 plus y. I'm doing it a little bit different now. Did you see? And it's 149. So 7 times 7 is 49 plus 7y plus 7y plus y squared plus y, and you can bring already the 149 over. Okay, so basically I have y squared, it's just 1y squared. So 7 plus y, let's just go to see that. So I just want to see 7, oh, plus another 7. So 7, 7, 1. So that's going to be 15y. So 15y. And then this, if I subtract, oh, this is very nice, and on the dot 100. Okay. Now it looks like it can factorize again. So let's make it 1 and 1, and let's make it 20 and 5. Because now it's in group B. Okay, so 20 minus 5 is 15. The biggest over cross product, the signs are different, is positive, and this is negative. So basically, I'm going to get y plus 20, y minus 5, and that's going to be equal to 0. Okay, so then y plus 20 equals 0, or y minus 5 equals 0. So y equals negative 20, or y is equal to 5. And now I substitute in my equation 1. So there x equals 7 plus y. So if y equals negative 20, x is equal to, let's just quickly write that down, 7 plus y. 7 plus y, and that's going to be 7 minus 20, and that is going to get negative 13. So, and if y is equal to 5, then it's going to be x is equal to 7 plus 5, and that is going to be 12. And then I'm just going to end with my nice conclusion. Therefore, when x is negative 13, I always start with the x. Then y is equal negative 20. And when x is equal to 12, then y is equal to 5. Okay, they didn't ask it as coordinates. They can. Just keep it in mind. Okay, I'm going to continue in the next video, but you know I always just like showing you. If you want to buy your own copy, it's now in the middle of the year. Go for a grand final this last 6 months. And then I'm also just now in this last videos, because it's the middle of the year, I like also to show the teachers the NEET catalog, and I highlight all the books, y equals mx plus c. So make sure you order your copies through the ministry, and so that you have textbooks next year.